Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about testing a claim for a single proportion. All right, so first we need to know what are the conditions that we need to check in order to do this type of procedure. So first, it has to be a random sample. Second, it has to be independent, so the population has to be greater than 10 times the sample size, or it has to be stated that it's independent. And 3, it has to be a normal distribution. So we have to have at least 10 successes and at least 10 failures. The probability of success times the sample size is greater than or equal to 10. The probability of failure times the sample size is greater than or equal to 10. So that's found by doing n times p and making sure it's greater than or equal to 10, or n times 1 minus p is greater than or equal to 10. All right. Calculating the test statistic. So our test statistic would be a z when we're working with proportions. So it's your statistic minus your parameter divided by the standard deviation of your statistic. So specifically when we're working with one proportion, z is equal to p hat minus p naught, whatever your parameter is, divided by the square root of p naught times 1 minus p naught over n. All right, given the test statistic, find the p-value. For a hypothesis test of your null hypothesis equals 0.55 against the alternative, p is greater than 0.55, the z test statistic is found to be, it's supposed to be a negative 2.15. What can be said about the finding? So if I go down and I want to find a z score of negative 2.15, okay, when I look at the z, you can see like there's a column across the top and or a row across the top and a column going down. I see a negative 2.1, and then across the top I see 0.05. So if I combine those together, where they intersect would be the p-value that corresponds to that z test statistic. So this p-value of 0.01578 is our p-value. So now we can interpret that. So would that be significant at an alpha value of 0.05? So in order to be significant, it has to be less than the alpha value. So we do have significant evidence. So this would be significant because our p-value of 0.01578 is less than our alpha value of 0.05. How about at an alpha value of 0.01? Okay, well, this one would not be significant. We do not have significant evidence because the p-value is not less than the alpha value. 0.01578 is greater than 0.01. All right. Finding the p-value and interpreting. A coin is used for a coin toss is suspected to be unfair. They believe it turns up more tails than it should if it were a fair coin. To check, you flip the coin 100 times and count the number of tails. This results in 57 tails. If you carry out a significance test, what is the p-value and conclusion you can make at a 90, 95, and 99% significance level? All right, so the first thing I need to do is kind of identify what my null and alternative hypothesis would be here. So my null hypothesis would be that p is equal to 0.5, the proportion of tails. And the alternative is that it's greater than 0.5 because we believe it's unfair. And I can see that I got 57 out of 100 instead of 50 out of 100. Okay, P is representing the true proportion of tails that are flipped when I flip the coin. All right, so if I use my calculator and I do a one proportion z-test, which I'll walk you through, you end up with a p-value of 0.0807. Okay, so now I need to determine, is this significant? What kind of conclusion would I make at a 90, 95, and 99% significance level? Well, for a 90% significance level, that gives us 5% on one tail. And so this would really be an alpha value of 5%. So 0.0807 is greater than 0.05. So we would fail to reject the null hypothesis. Okay, and we do not have sufficient evidence to support the alternative. At 95, that tail over there would be 2.5%. And again, 0.0807 is greater than 0.025. So we would fail to reject. Okay, your options are always going to be either you reject the null hypothesis or you fail to reject the null hypothesis. You're never going to say that you accept the null hypothesis. All right, at 99%, that leaves us with 0.5%. And again, our p-value is greater than that, so we fail to reject. Okay, so I want to show you how you do this, get this p-value in your calculator. So you're going to go stat, you're going to go over to test, and we are doing a 1 proportion z-test. 1 proportion z-test is option 5 here. It asks us for p-naught, which would be what you're setting your null hypothesis to. So that would be 0.5. X, we had 57. Tails out of 100 was n. And we were doing a greater than test, so we're going to change it to this one. And then you have two options. You can hit draw or you can hit calculate. I like calculate, it's a little faster, but draw makes a little picture and shades it in. It's nice as well. And so this p equals 0.0 or 0.080756. That is your p-value. All right, go Seahawks.